Good morning and good evening and good afternoon to you all. I'm Naoki Sato of JAXA. Thank you for inviting me to this exciting workshop. JAXA is very excited and honored to develop and provide Pressurized Rover to Uncrewed program. And we are now actually designing the Pressurized Rover, and we are very excited here. The many ideas from your side, and I'm very pleased to introduce current concept design of Pressurized Rover to you all. And please note that this information here will be is notional and only reference. So this concept may change as the project evolves. So actually, you are seeing the current industrial design of the Pressurized Rover. But if you come to the Osaka Expo, starting from this Sunday, you will see a little bit change or different design of Pressurized Rover. Next chart, please. Yes, first, I'd like to talk about the current Pressurized Rover concept of operation and operation. Next chart, please. So again, this is the latest design of the Pressurized Rover, and you see the big radiator, gray area is the gray radiator, and white area is the kind of bumper, and you see the window, and we have 6 for you, and solar array is installed configuration, and actually it will be deployed first deployed to towards the front, and then deployed vertically about 10 meters. And we have some several antennas, K-band, X-band, and S-band. Total length is about 6, and width will be about 5, and also the height is also 5. And wheelbase is about 4 meters, and breadth is 3 meters. Next chart, please. So this is Pressurized Rover mission overview, which will be launched in 2031, starting phase 1 operation. In phase 1, we focusing on the South Pole region on the lunar surface. So once per year, the crewed mission will be 31 continuous phase. And the other duration will be uncrewed exploration by remote operation from the ground. And after the phase 1, the phase 2 will start, which is only uncrewed mission going off the pole to maximize science result. Next step, please. So this chart summarizes the mission concept and the system requirements at this moment. So for phase 1, the number of crew is 2, but there's no crew in phase 2. And the exploration area is South Pole 18 region in phase 1. In phase 2, we will be able to go, for example, the SPA basin or Nectar area. And the crew mission is current is 1 crew mission per year, and the duration is 31 days for phase 1 with crew mission, including a 3 days margin. And period of extended darkness, that means the night survival duration is 36 hours for crewed mission and 192 hours for uncrewed mission. And for the phase 2, the night survival capability will be 14.5 days. And traversing distance is 18 kilometers per day mission per battery charge. And total life traverse distance is 10,000 kilometers, and operation mass is 18 tons, and cargo mass is 3 tons. That means the actual pressurized rover dry mass will be 15 tons. And EVA frequency will be able to conduct 24 hours EVA per crew per week, and maximum 3 times EVA per week, but we will be able to run contingency EVA within 2 weeks. The maximum velocity is 50 kilometers per hour, but this is for the very flat area. But actual operational speed will be 2 to 3 kilometers per hour. And maximum slope is plus minus 15 degrees. And maximum obstacle is 30 centimeters on the flat surface, that's 7 centimeters for 15 degrees. Next chart, please. I'll be talking about a little more operational concepts, but this first chart shows a very high-level overview, which was explained before. But so once the crew lands by HLS, the crewed mission will start about 1 month. Then the crew will return to the Earth through the gateway. Then the uncrewed mission will start for 11 months. Then another crewed mission will start. So this is the overview of the 1-year cycle of the Artemis mission. Next chart, please. So this chart shows a little bit more detailed operation in the uncrewed mission. So looking at the bottom chart, so the first day the crew will return from the lunar surface to the Earth, then start the uncrewed mission. So day 2, we can traverse and robotic exploration for 8 hours. Then we need to park and recharge the battery for 16 hours in day 2, and also we need to recharge the battery in the next day, day 3. Then we will repeat the day 2 and day 3 operations. Then we can do the lunar night survival from up to 8 days. Then we will repeat the operations during the remained uncrewed operation about 300 days. Actually, during the lunar night survival, we will use here a degenerated plate for half-speed energy. Next chart, please. This chart shows how we're going to swap the payload at the transition to uncrewed phase and also transition to the crewed phase. So in the bottom left, it here shows the transition from the crewed phase to uncrewed phase. So the crew will remove the crewed payload and retrieve samples, then transfer the payload and samples to the HLS. and the crew then transferred uncrewed payload, the payload for uncrewed mission from the cargo lander or HS to the pressurized rover. And on the right, this figure shows the transition of payload from uncrewed to crewed phase. So landing crew will transfer the payloads for crewed mission from HLS or cargo lander to the pressurized rover and replace or remove the payload during uncrewed mission, uncrewed mode, and retrieve the sample, then transfer these samples or payloads to the HLS. That is the concept of how to change out the payload. Next chart, please. So from now, I'd like to talk about the current expected utilization capabilities of the pressurized rover. Next chart, please. So as for the payload accommodation, for the external attached payload or external target different payload, we provide the power and data communication connections and also the mechanical attachment at 4 locations in the vehicle where the EVA can swap out is feasible. Also, we accommodate additional mechanical attachment locations for surface deployed payload. And for the robotic grapple payload, we will have a robotic arm which provides the mechanical or electrical interface for the payload or suite. For the internal payload, we have two kinds of, we can have accommodate two kinds of payload. First one is the internal mounted payload. We also provide power, data communication, mechanical attachment for 2 payloads, and we will accommodate another 2 having deployed payloads. We also have a power outlet and data connection. And we have storage accommodations, and actually we have 2 types of sample storage, ambient and passive core, and also we have storage for the utilization EVA tool. As for the payload operations, we provide the CNDH functions for the operation payload by either through or remote from the remote operator on the ground. And data generated by payload may be stored locally on the pressurized rover. And also we have a capability to downlink those data to the ground as the bandwidth allows. And also the several pressurized rover system data, such as location, temperature, will be available on the ground to support the science data calibration needed for their accurate interpretation. Next chart, please. Actually, this chart shows what I have explained before. Again, for the external payload, we have 28 volt and also 120 volt DC power and Ethernet communication, and data can be transmitted to the Earth. And for the internal mounted payload we can accommodate the cold plate for this payload to display the speed from the payload. And on the most right-hand side, you can see the current concept of the external payload mount location. We have 4 locations the current concept is to have one payload on the front, bottom, and two payloads on the side, and the last one is on the rear. It's just this is the last one. We have a robotic arm on the back side. The main objective is to perform the exploratory tasks by instruments and tools on the tip. And the current concept degrees of freedom is 57, and maximum reach of 2 meters from the base and 1 meter from the ground projection point of the base. And in the folded posture, we can handle 200 kilograms, but for the extended posture, it's going to be 50 kilograms. And the positioning accuracy, 5 millimeter without visual feedback, and plus minus 1 meter with visual feedback. I think that's all for my presentation. Thank you very much.